Some important points to do the numericals of sound. See, the main important formula for chapter sound to solve the numericals is V is equal to lambda into nu. So V is nothing but velocity or speed, and lambda is wavelength of the wave, and nu is frequency, and units are meters per second, frequency hertz, wavelength meters. So in the problems, either lambda is asked or nu is asked, or velocity or speed is asked. If velocity or speed is asked, no problem, you can directly use this formula. Wavelength is asked, lambda is equal to V by nu. Same formula but written in a different way. Then you have to write the units also for lambda, meters. Then comes how to calculate nu. Nu is equal to again V by lambda. So units are for frequency hertz. One more formula for frequency is nu is equal to 1 by t. Sometimes time period is given, frequency not given. Then time period we have to substitute and calculate the frequency. Later on substitute in the formula to get the speed or velocity. Now if velocity is not given, distance and time are given, use the formula speed is equal to distance by time. And in case if number of waves are given, then frequency is equal to number of waves per unit time. And if time period is given, same formula can be reversed, 1 by nu. And if number of crests and number of troughs are given, then use the formula 1 wave is equal to 1 crest plus 1 trough. And roughly one vibration can be taken as 1 second. So indirectly, if directly the question comes as find out the velocity and wavelength and frequency are given, we need to apply this formula. Otherwise, if velocity and frequency are given, lambda can be found. Or velocity and wavelength are given, frequency can be found. If time period is given, frequency can be found. Or time period is given, frequency is given, time period can be found. And if distance and time are given, velocity can be found. This way we can easily calculate using these formulas the numericals of sound. Now coming to the examples. Sound waves travel with a speed of about 330 meters per second. What is the wavelength of sound whose frequency is 550 Hz? Here velocity is given, frequency is given, and wavelength is asked. So use the formula velocity is equal to lambda into nu. Lambda is equal to V by nu, convert it, and we get the answer after division, 0.6 meters. For any problem, given data should be written, solution, and units are important. The wavelength of sound emitted by a source is 1.7 into 10 power minus 2 meters. Calculate frequency of sound if its velocity is 343.4 meters per second. So here wavelength is given, velocity is given, frequency is asked. So frequency is equal to velocity by lambda. So frequency after division we get 2.02 into 10 power minus 4 Hertz. If a thunder is heard by a man for 4 seconds after lightning is seen, how far is the lightning from the man? So here distance is asked. Velocity is given, time is given. So velocity is equal to distance by time. So distance is equal to velocity into time. So which is equal to 1320 meters. Next, a source is producing 1500 sound waves in 3 seconds. If the distance covered by the compression and adjacent rarefaction be 68 centimeters, find frequency, wavelength, velocity of the wave. So frequency is equal to number of waves by time, we know. So number of waves are given as 1500, then divided by time 3 seconds, we get 500 hertz. Then lambda is equal to 68 centimeters. So 68 centimeters should be converted into meters. How to convert it? 1 centimeter is equal to 1 by 100 meter or 1 into 10 power minus 2 meters. So here 1 by 100 we have used, which is equal to 0.68 meters. V is equal to nu into lambda to find out the velocity when nu and wavelength are given. When multiplied, we get the value 340 meters per second. Now this is a different problem where gravity is given 10 meters per second. So a stone is dropped from a 500-meter tall building. Imagine there is a tall building and it is 500 meters tall. So a stone fell from the building into a pond which is there near the building. So when is the splash heard? So here given things are g is equal to 10 meters per second and velocity of sound is 340 meters per second. So as height of the building is 500 meters and gravity is given as acceleration due to gravity is equal to 10 meters per second square, u is equal to 0, where u is the initial velocity. As when the stone is thrown, initially it doesn't have any velocity, so it is 0. This is one of the equation of motion where s is equal to ut plus half at square. S is the distance, u is the initial velocity which is 0, t is the time, and a is acceleration due to gravity which is value g. So after substituting, t1 is the time taken to throw the stone reaching the splash. So T1 we can find from the equation of motion. Then we have velocity which is equal to distance by time. To find out T2, T2 is nothing but after splash the sound should reach us. So that is the time taken to reach sound to our ears. Then T2 is equal to 500 by 340. So as velocity is equal to distance by time, time is equal to distance by velocity. So distance is 500 meters, velocity is 340 meters. Sorry, distance is 500 meters, velocity is 340 meters per second. So time will be 1.47 seconds. So we can hear the sound at 1.47 seconds. So this is a different problem where we use equation of motion. And here conversions are also important in the problems. So height or distance should be in meters. If given in centimeters, say 1 centimeter is equal to 10 power minus 2 meters. Or 1 meter is equal to 100 centimeters. Okay. Or if 1 by 10 power minus 2 is given, and if it is sent to the numerator, we get value 10 square. So as 1 by a power minus m, which is equal to a power m. Use this. And if kilohertz are given, then 1 kilohertz is equal to 1000 hertz. If kilometers are given, then 1 kilometer is equal to 1000 meters. If time is given in hours, then it should be converted into seconds. If time is given in minutes, it also should be converted into seconds. So finally SI units should be used. Then only the problem need to be solved.